US Physics Olympiad, year 2019, first round, F equal MA, exam B. This year exam was split by two flows, exam A and exam B, and the students could participate in any of them. For exam there were, as usual, 24 problems, and that was given 75 minutes for this amount of problems. If you want to get more interesting problems in physics, just subscribe for this channel. Problem number 1. A uniform block of mass 10 kg is released at rest from the top of an incline of length 10 meters and the inclination 30 degrees. The coefficients of static and kinetic friction between the incline and the block are mu static equal 1.15 and mu kinematic equal 1.1. The end of the incline is connected to a frictionless horizontal surface. After a long time, how much energy is dissipated due to friction? Solution for problem number 1. Because inclination 30 degrees greater than critical angle, it means that tangent 30 degrees greater than mu static, there will be motion on this incline, and all energy dissipated due to friction, it's because of work done by force of friction. And this we can count using a regular formula. Work of force of friction equal force of friction multiplied by distance, which is mu kinematic mg cosine theta multiplied by L. After putting numbers, we will get 87 joules. This is answer B, and this is the solution for problem number 1. Problem number 2. 3 cubical blocks of the same volume are made out of wood, styrofoam, and plastic. When the plastic block is placed in water, half of its volume is submerged. If the wooden block is placed in water with the plastic block on top, the wooden block is just fully submerged. Similarly, if the styrofoam block is placed in oil with the plastic block on top, the styrofoam block is just fully submerged. The density of oil is 0.7 times that of the water. What is the ratio of the density of wood to the density of styrofoam? Solution for problem number 2. First, let's say raw water equal 1. It means that raw oil equal 0.7. When the plastic block is placed in water, half of its volume is submerged. We can write equation volume V multiplied by raw plastic equal 1/2 volume V multiplied by raw water. It means that raw plastic equal 0.5. If the wooden block is placed in water with the plastic block on top, the wooden block is just fully submerged. We can write equation volume V multiplied by raw wood plus volume V multiplied by raw plastic equal volume V multiplied by raw water. Here we know what is raw water and raw plastic, and the raw wood equal 0.5. If the styrofoam block is placed in oil with the plastic block on top, the styrofoam block is just fully submerged. We can write equation volume V multiplied by raw styrofoam plus volume V multiplied by raw plastic equal volume V multiplied by raw oil. Here we know what is raw oil and raw plastic, and we can find what is raw styrofoam. That will be 0.2. And now we can count what is raw wood over raw styrofoam. That will be 2.5, which is answer A, and that was a solution for problem number 2. Problem number 3. Two springs of a spring constant K1 and K2 respectively are connected in series and stretched as shown below. What is the ratio of their potential energies? U1 over U2. Solution for problem number 3. First, we can write the equation for force F. That's equal to K1 x1 plus K2 x2, where x1 and x2, that's the extension for the first and second strings. Second, we can write equations for potential energies. U1 equal 1/2 K1 x1 square and U2 equal 1/2 K2 x2 square. And now we can write relation between these energies. That will be this expression, and after simplification, because K1 x1 equal K2 x2, we have finally it's equal to K2 over K1, which is answer C, and this is the solution for problem number 3.